Hello, and welcome to an introduction to using the Estimating Tree Community Hurricane Resistance Tool, or ETCHR for short. I'm Dr. Allison Salisbury, one of the creators of the ETCHR tool. This presentation begins by providing background on the development of ETCHR. Then it takes you step by step through using the tool. Hurricanes can cause substantial damage to communities and their urban forests. On average, hurricanes cost over $17 billion in the US each year. Hurricane damage to trees directly impacts communities through damage to infrastructure and property. And hurricane-generated tree debris drives up cleanup costs quite substantially. Plus, the loss of tree canopy means that we lose many of the ecosystem services that urban trees provide. The good news is that we do have management strategies that can mitigate or reduce the likelihood of hurricane wind damage to urban trees. Many different factors influence the likelihood that a hurricane will severely damage an urban tree. These factors include the tree species, the size of the tree, soil conditions, its management history, tree condition, the severity of the storm, among others. ETCHR focuses on the species aspect of hurricane damage. Many studies have demonstrated that tree species vary in their ability to resist wind damage. We can use such information to plant wind-resistant species in places where tree damage could cause greater harm, such as near utility lines. Back in the early 2000s, Mary Duria and other researchers in Florida developed a wind resistance rating system for tree species. This research was conducted after a series of hurricanes impacted the state in 2004 and 2005. They developed their rating system based on observations of hurricane tree damage, species characteristics, and expert opinions. Their research rated 145 palm species with the lowest, medium-low, medium-high, or highest wind resistance ratings. While this was very much a comprehensive body of research, many urban species are not accounted for in the original rating system. And unfortunately, the approach the researchers used is not easily repeatable to allow you to add ratings to new species. So to expand the rating system, our research team collected hurricane damage from 58 other studies and used that data to create a model that can predict the wind resistance rating for new species. In our first round of modeling, we were able to assign wind resistance ratings to 281 additional tree species. And these are species found from all over the world. Second, so we put these new species, plus the ones from the original rating system, into the ETCHR spreadsheet. ETCHR has two primary functions. First, you can use it to find the wind resistance rating of a particular species. Second, if you have a tree inventory, you can add that inventory data to the spreadsheet and determine the proportions of wind-resistant species in your community. In this next part of the presentation, I'll demonstrate some of the different ways to use ETCHR. So you can download a copy of ETCHR from the project's GitHub page, Trees for Hurricanes. And you'll see the website includes an overview of the project and then links to download the ETCHR workbook, which you can click on and then save in a location that's convenient for your computer. So once ETCHR is downloaded, you'll notice that there are several different sheets available within the workbook. First, we have the introduction, which again contains background of the project and an overview of the contents of the workbook. Here we have a copy of the instructions for using the tool. The data input sheet is where you would add your inventory info that then gets presented on the summary page. The species sheet is the full list of all of the ratings for this species, plus some additional information about how those ratings were based and where the species data came from. The Notes tab defines all of the columns in the species sheet. And then this alt rating sheet is just necessary to help the spreadsheet work well, so you can ignore that. Let's begin with an example to look up a single species. One way to do this is to click on the Species tab. And here you have an Excel table that you can use to sort the header row at the top. So right now, this little arrow indicates that the species table is sorted by scientific name. You can also sort it by common name over here, if that's more convenient for you. Though note that we don't have every single common name for a species. So we recommend looking up by scientific name is probably more efficient. So let's say you wanted to know which oak species have ratings. And there's a few ways you could do this. You could begin by filtering by family for all of the Fabaceae, which is the family that contains oaks. You would begin by unselecting everything and then scrolling down to find the family of interest. So Fabaceae in this case, we tell it okay. And then we get a list of mostly oaks, plus a few beeches and lithocarpus of all of our Fabaceae species that have ratings. And you can scroll to the right to see what those ratings are. You'll note that when a filter is applied, this funnel shape appears in the column to let you know that not all of the rows of the table are being shown. We can remove the filter by clicking the Clear Filter option. Another way to search for species is to go directly into the scientific name and clicking on the search bar, where you could start typing in the beginning of a species or genus in this case, and you'll start to see all of the options that have the letters that you've typed begin to appear. And so this is another way you can search for individual species. Next, I'll show you how to add inventory data to the data input sheet, which is this one right here. You'll need to have a tree inventory that lists the number of species for all of your trees, or the number of trees for each species in your community. The sheet is designed to be searched by scientific name, so you'll want to have that information handy as well. Let's say the first species in your inventory is red maple, or Acer rubrum. You'll come over and click into the first row of the scientific name column and start typing the name of your species. So in this case, Acer, and you'll see options that start with the same few letters will appear in the drop-down list, and we'll see that Acer rubrum is included in our wind resistance ratings. And by clicking on it, several other columns are populated in the table. Once you've found the scientific name for your species, you can then add the quantity of trees in your inventory. So you can repeat this process then for other species in the inventory. For example, we could add sweet gum, which is liquidambar styrosiflua. And again, we get this convenient auto population. And then we add in the tree quantity. Let's also add in ginkgo biloba as another example. In addition to the wind resistance rating, you'll notice that the table contains a confidence column. This tells you how good that we think the model's wind resistance rating is. If a species comes up with an original rating, that means that it was part of the original Duria rating system, whereas trees with low, medium, or high confidence were rated using the model we developed. A species generally got a low confidence score if its input data set was somewhat incomplete and we had to make some predictions about species characteristics, or if the model was just more uncertain about the rating it was assigning. So when you see a low confidence rating, you may want to take that with a grain of salt. Now, let's say you disagree with the wind resistance rating based on your experiences in your region or in your city. You can adjust the wind resistance rating to better match local conditions by clicking the drop-down menus in the alternate wind resistance rating column, which is right here. You'll see when you click on the drop-down tab, you get options to replace the wind resistance rating with lowest, medium low, medium high, and highest. So perhaps for ginkgo biloba, based on your experience, perhaps rather than medium low, you feel it should be ranked lowest. And now the final rating has been replaced with the rating that you've assigned. And I would recommend that if this is the results of this summary are something that you are using in a report, to be sure to document which species that you alter the wind resistance rating for, and document how you change it to better fit your local conditions for the purposes of transparency and consistency if you're planning to use this tool in the future as well. So while ETCHR contains over 300 species, it's very likely that some species in your inventory may not be included in ETCHR, or at least in this current version of it. Hopefully we'll get to add more species in the future. When that's the case, you're going to choose, so for example, Quercus bicolor, common street tree in the Northeast, is not included in ETCHR. So when that's the case, you are going to, oops, that's not right. And when that's the case, you're going to assign the scientific name to be unknown. And you'll see that auto populates an unknown wind resistance rating. For the sake of keeping track of your inventory in the spreadsheet, you can manually add in the name of the species in the common name column. So swamp white oak. And then add in the tree quantity as you normally would. If you have an opinion on the species wind resistance rating, you can manually select that in the alternate wind resistance rating column, or again, you could leave it blank as well. Again, if you are manually altering the wind resistance rating, be sure to have that clearly documented in any reports related to the ETCHR output that you use. So once you've added all of the species in your inventory, you can go to the summary page to see your results. Start by making sure that your total quantity of trees matches what's in your inventory to make sure that all of your numbers jive. And then you can take a look at the proportions of the population that's composed of the lowest, medium low, medium high, and highest, as well as unknown or unknown species. And that's how you use the ETCHR spreadsheet. For suggestions on how to use the output from ETCHR, check out the companion guide document, which is also available on the GitHub project website. So, unfortunately, we can never completely eliminate the risks that hurricanes pose to the urban forest. But our hope is that these expanded wind resistance ratings will provide an additional tool to help mitigate some of those risks. And through mitigation activities, our communities can help balance the many benefits provided by the urban forest with the costs of hurricanes and other natural disasters. Thanks for your time and an interest in ETCHR. Be sure to keep up with the project on our project webpage.